Hello friends, in this video we are going to answer the questions of ray optics which are asked in 2025 ACS final examination under Assam Higher Secondary Education Council. Okay, so before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. And this is my Insta ID OJHALAKHYAJIT 123. This is my Insta ID. You can follow me on Insta. Okay, so now let's see what are the questions asked in 2025 ACS final examination. So let me check. So here is the question. You see, mention the condition where Snell's law of refraction cannot be satisfied. The condition is, I greater than IC. That means if the angle of incidence is greater than angle of critical angle. So let me write the answer. So this is the condition that I greater than IC, where I is the angle of incidence and IC is the angle critical angle. If angle of incidence is critical greater than critical angle, then Snell's law of refraction cannot be satisfied. Okay, so this was asked in 2025. Okay, so now see, let me check what is the next question asked in the same year from this chapter. Okay, so here you see, so in the case of spherical mirror, f is equal to r by 2. So f is equal to r by 2, that has to be proven here. So now you see, I have already made a video on this topic where I have proved this f is equal to r by 2. Link is in the description box. Okay, so I have written question number 2I and I have provided the link. Okay, this is question number 2I, 2 marks question. So question number 2I. Okay, so next question, this is question number 2J. What is the focal length of convex lens of focal length 30 centimeter in contact with concave lens of focal length 20 centimeter? Is the system converging or diverging lens? So let me show you how to solve this question. Okay, first let me take a new slide. So here you see, what is the focal length of convex lens of focal length 30 centimeter in contact with concave lens of focal length 20 centimeter. So we have a convex lens and we have a concave lens in contact. Okay, so both are in contact like this. Let me show you. So this is concave and convex. These two lenses are, this is convex lens and this is concave lens. These two are in contact and both have different focal lengths. Okay, so we know that the focal length of combination of lenses in contact is given by, if there are two lenses f1 of focal length f1 and f2. Suppose here let me write focal length of the convex lens, focal length of the convex lens, this is suppose f1, which is, so convex lens, so that's why focal length will be positive 30 centimeter, and that of concave lens and that of concave lens, so let it be f2, that is minus 20 centimeter, because here it is concave lens. Okay, so here you see the equivalent focal length of this system. Okay, so the focal length f is the focal length of this combination, okay, of this system, that will be given by 1 by f is equal to 1 by f1 plus 1 by f2, that is equal to 1 by 30 minus 1 by 20, right? So if we take LCM, that's going to be 60. 2 minus 3, that's going to be minus 1 by 60. So focal length of the system, okay, focal length of the system, or the combination of lens, focal length of the combination, that is f is equal to minus 60 centimeter. 1 by f we have got minus 1 by 60, so f will be minus 60 centimeter. Negative sign indicates that it is diverging. Okay, the system is diverging, because for diverging lens, concave lens, we know that focal length is negative. So since the focal length is negative, so write the proper spelling. Okay, don't write this way in exam. Okay, negative, so system is diverging, right? So hope you have understood this. Now let's move on to next question. So our next question is, this is 3E. This is question number 3E. Okay, so here we need to prove this relation. Okay, a ray of light is suffering a refraction at a spherical surface. I have already made a video on this topic. Okay, and the link is in the description box. I have written question number 3E and I have given the link there. Okay, just click the video and you will get the notes as well as the explanation of this topic in the same video. Okay, first I have given the handwritten notes in the video, then I have explained it as well. Okay, now let's move on to the next question. What is the next question? This is a numerical again. So same question, actually same question number. Here either you have to solve this or you have to solve this. Okay, same question number, but here is another option, alternative. You can solve either this one or this one. Okay, so now let me solve this. So find the position of the image formed by the lens combination given below. So here is the lens combination given below. First let me take this as first lens and let me take this as second lens. Okay, so for the first lens, so object distance is 30 centimeter. This object distance is 30 centimeter. This should be the diagram actually. Okay, for the first lens, okay, object distance, that's going to be minus 30 centimeter because this side is negative and that side is positive, right? Now here you see focal length for convex lens, that is positive 10 centimeter. So let me find the image distance for this first lens. Okay, for this lens, so let me make it white. Okay, so now let me use the lens formula. So according to that, 1 by v minus 1 by u is equal to 1 by f. So 1 by v is unknown, 1 by u is minus 30, so that's going to be equal to 1 by f is 10. Okay, so here you see this minus plus, right? So on the other side of the equation, when you shift this term on the other side, that's going to be negative again, because now it is minus plus, on the other side it will be minus. So 1 by v, 1 by 10 minus 1 by 30. So let me solve it. That's going to be 30 here, 3 minus 1, so here 2 by 30, so that means 1 by 15. So that's why v gonna be equal to 15 centimeter. So v gonna be equal to 15 centimeter. That means that image is formed on this side. Okay, so here v is positive. For lens, v is positive means image is real image, and here it is 15 centimeter away from this first lens. Okay, 15 centimeter away from this first lens, and distance between these two lenses is 5 centimeter. So it is 15 centimeter, so that must be on the right hand side of the second lens. Okay, and this distance is 15 centimeter, so that's why this distance must be 10 centimeter. 15 minus 5, that is 10 centimeter. And for this second lens, this image will be the object. Okay, this image will be the object. So let me simplify it for the second second lens. Okay, So now let me take a new slide. Okay, so first part is done. Okay, instead of taking new slide, let me solve it here. Okay, let me make it white. So let me solve the next part. So now you see, for the second lens, this image will be the object distance. So here object distance will be 15 minus 5 centimeter, right? Because you see, this image is formed 15 centimeter away from this first lens, and the distance between these two lenses is 5 centimeter. That's why this image is now this image will be now object of this lens. So object distance from this lens, that's going to be 10 centimeter. Okay, and it is concave, this side is concave. Okay, this side is concave, so focal length here it is negative minus 10 centimeter, right? Minus 10 centimeter. So it's supposed to be 10 centimeter as well. So now let's find v. 1 by v minus 1 by u is equal to 1 by f. So here 1 by v minus u is equal to here 10, on the other side again minus 1 by 10. So here you see this minus 1 by 10 minus 1 by 10 cancel, right? Or you can write this way, that let me make a boundary here. Okay, so here you see 1 by v, if you shift this term to other side, that will be minus 1 by 10 plus 1 by 10, which gives you 0, and this is 1 by v is equal to 0. That means v is equal to reciprocal of 0, that is infinity. Therefore the image will be formed at infinity, right? So the position of the object is at infinity. So here let me write the statement. Okay, just so what we have got. So therefore the position of the image, at infinity, right? So hope you have understood this, how to solve this problem. So thank you for watching. See you in the next video. Bye bye.